VLANs are one of the coolest things since sliced switches. Sliced switches? That makes no sense whatsoever. A VLAN is a subnet built on a switch. Now, I know that kind of doesn't make any sense because subnets are made up of IP addresses or subnetted IP addresses. However, switches are capable of doing that, even though they're not capable of routing by IP address. So here what I've done is I've said, well, this port belongs to VLAN 1, this port over here belongs to VLAN 3, this port here belongs to VLAN 2, this port belongs to VLAN 3, and so forth. Now I have a trunk line here between these two switches, and again I've got a VLAN 1 here, and a VLAN 2 here, and a VLAN 2 here, and so on. Now VLAN 1 devices, VLAN 1 computers, can all talk to each other. They're all on the same subnet. But VLAN 2 is on a different subnet. I've got two of them over here. I've got one over here. I've got one up here. They're all on a different subnet from VLAN 1. They can talk among themselves, but they cannot talk to anything on VLAN 1. Likewise with VLAN 3, I've got one over here. I've got one over here. I've got another one down here. Those can talk among themselves, but they can't talk to VLAN 1 or VLAN 2. Now, there are ways in which we can do that. We could add a router to one of these ports and use that router to route from one subnet to another subnet. That would be perfectly valid to do. Another thing we can do is to use what we call a layer 3 switch, which has the capability of moving information between VLANs. Now, it doesn't have full routing capability, but it does have the capability of moving information from one VLAN to another. Why would we do this? Well, to separate broadcast domains, for example, or for security purposes. I can put my admin on VLAN 3 and my production on VLAN 4 and my payroll on VLAN 5 like that, and that way they're all separate from each other and they have to go through the rules of the router in order to be able to talk to each other. Just for fun, I thought it might be cool to actually look at VLANs on an actual switch. Right now, what we're looking at, let me clear that out. What we're looking at is a switch that I've got attached to my computer right now. It's the one that I use at home because I have several computers in this room, and so I can separate them all out if I wish. And I could do some damage here. I have to be careful what I do, or I have to at least undo it when I get done. So if I do show VLAN right now, you see that I've got all of these computers, or all these ports on my switch are all on VLAN 1. So I've got all fast Ethernet ports except for a couple of gigabit Ethernet ports. And then on VLAN 2, well, I don't have any on VLAN 2. I've got port 103 on VLAN 3. I've got 4 and 9 on VLAN 5. Now, VLAN 99 is a default one. We don't really use it often. And same thing with 102, 3, 4, and 5. Those are built into the switch, and we can't change those. So we can't use those numbers. So just for fun, let's go ahead and put, let's put port 16 on VLAN 2. All right, let's do that. Port 16 on VLAN 2. First, I got to get into configuration mode, and then I've got to get into the interface. 1016, did I say? FA 1016. So now I'm in that interface, and I'm just going to say switch port access VLAN. What did I say? 2? VLAN 2. And now let's go back again and take a look at show VLAN, and now I've got 16 on VLAN 2. So that's how we would actually configure the ports. You don't need to know how to do that, but I thought it'd be fun to show you. For the MTA purposes, you don't need to be able to do that. Now what's going on here is tagging, and we saw in another video a frame, and the frame we notice has a field here for the VLAN tag. So when, let's say that we're talking from this PC down to this PC on VLAN 1. So this PC sends the frame here, and it doesn't know anything about the VLAN tag. But the switch adds this VLAN tag and says, oh, that's VLAN 1. It also knows that this is a VLAN 1 port, so it says, yes, I will send that information down to this computer. If I tried to talk to this computer and say, it does not have the correct tag, so as it goes across this switch, it would not allow it to go out of that port. It also tags it at the trunk, so that it goes across the trunk in a tagged format, and then it's untagged before it's sent out to the other computer. So that tag is put on at this switch port, taken off at the output switch port. The computer never knows about that tag.